Okay, welcome to video number 6, solving inequalities. When we solve inequalities, we're going to oftentimes have to graph them on a number line. So take a look at the symbols that we need for graphing them. When we see a greater than or less than symbol, we're going to use an open circle on a number line. And I'll show you what that means in just a second. Whenever we see greater than or equal to or less than or equal to, we're going to use a closed circle because that means it includes that number. So when you see this line underneath or equal to, we're going to use a closed circle. So for example, when I see x is less than 2, that means that's going to include all numbers less than 2. So I'm going to use an open circle over the 2 because it doesn't include the 2, but it does include all the numbers that are less than 2, like 1, 0, -1, and so on. So when I shade it, I'm going to shade it in this direction. Okay, for this type of problem where we have 3 is less than or equal to x, be careful because x is on the other side of the inequality symbol. So this is the same thing as x is greater than or equal to 3. So that means it includes all numbers equal to or greater than 3. So that means 3, 4, 5, 6, and so on. So I'm going to put a closed circle on top of the 3, color it in, and shade up. When we solve inequalities, we're going to solve them and treat it like we would an equation. So imagine that this was not a greater than or equal to, instead that it was just an equal to. Think about what steps we would do to solve. The first thing I would do is add 6 to both sides. Remember, these make your 0 pairs. These are canceled out. I'm left with 2x is greater than or equal to, now I've got -4 plus 6, which is +2, and now I've got one more step to solve. 2 times x, inverse of that would be to divide by 2. If I do it to one side, I must do it to the other side, and x is greater than or equal to 1. So same steps that I would do if it was equal to, except I've brought down my greater than or equal to sign. Remember, to graph it, it's based on what symbol is here. Greater than or equal to means it's going to be a closed circle because it could include 1. And greater than means all numbers greater than 1. So I'm going to do a closed circle over 1 because it could include the 1, and shade up because it could include 1, 2, 3, 4, and so on. Okay, here's a little bit more complicated one. In this one, we've got -x divided by 7 plus 5 is greater than or equal to 3. So my first step is to subtract 5 on both sides. 3 minus 5 is -2. Bring down my greater than or equal to, and bring down my -x divided by 7. Okay, now remember, inverse operations tells me that the opposite of dividing by 7 is multiplying by 7. So I'm going to times both sides by 7. These are canceled out. Be careful, this negative has not gone away. So -x greater than or equal to -2 times +7 is -14. Remember, invisible in front of this x always is a 1, so that means if there's a negative, it's a -1. This is -1 times x. So the inverse of that would be to divide both sides by -1. Now something special happens when I divide both sides of an inequality by a negative. When I multiply or divide both sides of an inequality by a negative, the sign, meaning the inequality sign, is going to flip. So it goes from greater than or equal to less than or equal to. And that's connected to the fact that a negative and a negative multiplied or divided gives us a positive. It reverses our direction on a number line. So negative 14 divided by negative 1 is positive 14. And now I've got my x all by itself. So whenever you divide both sides by a negative, I told you it's like a siren going off. Woo, woo. You have to flip the sign. So whenever you do that, make sure the siren goes off in your mind. Now, for the inequality graphing, we've got less than or equal to 14, which is going to be a closed circle. So let's put our 14 here, put some numbers around it. Okay, so closed circle on 14, because it could include the 14. And I'm going to shade in this direction, because it includes all numbers less than or equal to 14. Okay, last thing, let's do a word problem together. It says John is saving money. He makes $10 for each lawn he mows. He has $25 saved. How many lawns does he have to mow to save at least $100? Notice this phrase, at least. That's important to keep in mind for an inequality. We say at least $100. So let's write an equation. We know he makes $10 for every lawn that he mows. So that's $10 times M. We know that he's already saved $25, so we're going to add that on. It's money that he already has. And he wants to save at least $100. So that means he'd be okay with going over 100, but he doesn't want to go under 100. So that means the inequality symbol would be greater than or equal to 100. Okay, inverse operations to solve. Let's subtract 25 on both sides. Okay, now I'm left with 10m, 10 times m, is greater than or equal to 75. Opposite of timesing by 10 is dividing by 10. So m is greater than or equal to 7.5. So to graph that, I'm going to graph it with a closed circle greater than or equal to on 7.5. In between 7 and 8, and I'm going to shade up. But be careful, because John can't mow half of a lawn. So when it comes to actually taking this back to the real world, in order for John to earn that $100, he's going to have to round up to at least mowing 8 lawns.